We're going to spend this week working with two different laws of sine and law of cosine are the two things that we're going to work on this week. Prior to break, we practiced using trig ratios to find side lengths and angles of right triangles. So we said sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, tangent was opposite over adjacent. When we talked about those, we talked about that only works if you have right triangles. You have to have a 90-degree angle. If you don't have a right triangle, you can't use SOHCAHTOA. So there's another way that we can find missing sides and missing angles of triangles using two different laws. The one we're going to talk about today and what we want to be able to do today is we want to be able to use the law of sines to find missing sides and missing angles of non-right triangles. Okay. So the law of sines, you don't need to put all of this. This is just too much. We'll just give it to you in a second. I'll just explain what it is. The law of sines shows the proportional relationship between the angles and their opposite sides. It can be used to find the lengths and angle measures for any triangle. So the law of sine works for any type of triangle you have, whether it's right, acute, or obtuse. But you have to know a couple different things in order to do this. So the first thing I want you to do in your notes, law of sines, and then I want you to draw that triangle and label the triangle exactly how it has labeled with both upper and lower cases. And you'll notice that the upper case is the angle, the lower case is the side opposite of that same letter. Again, just to kind of remind you when we're talking about angles and opposite sides, these two, that angle and that side, they're opposite of each other. Okay, they have the same kind of letter. Angle A and side A are opposite of each other, and C are opposite of each other. And one of the things that we have to have when we're using the law of sines is we need to know the measure of one angle and the measure of its opposite side. And then you just need one other thing to find everything else. But the proportion that you have to have, a ratio that you have to have, is you have to know the one angle and the length of its opposite side. So what the law of sines says is it says if you have that, then if we're given triangle ABC, the sine of capital A over side A, that ratio, whatever's created there, that's going to equal the sine of angle B over the length of its opposite side and the sine of angle C over the length of its opposite side. And there's a proof to this. It's all, you can draw right triangles and you can do all those different things. With this, we're not going to worry about the proof so much. We're going to worry about what this law says. Now, within this law, like I said when I was over there, you have to be given three pieces. The first requirement is that you have to know the measure of an angle and the length of its opposite side. That's always going to be our first ratio. The A's and B's and B's and C's and C's really don't mean anything other than to show you that angle A is opposite side A, angle B is opposite side B, and so on and so forth. Okay? We have to know the measure of one angle and the length of its opposite side. That's going to be the first ratio that we always write. Okay? We're going to then set it equal to another proportion of something that we know along with something that's missing. Okay? So if we look at this first example right here, we're going to use the law of sines to find the value of x. So we've got this triangle that has side lengths of 12 and x. It has angle measures of 71 and 35. We're just going to find the value of x today. So we're going to use the law of sines to do this. First thing you have to look for is you have to look for a side length and an opposite angle to put together. So if I look at 12 and 35 degrees, those are opposites of each other. We've got an angle that's 35 degrees and we've got a side length that's 12 degrees. So I can write a ratio for that to say the sine of 35 divided by 12. That's the angle, the sine of the angle divided by the length of the side. Now, that's going to equal the ratio of an angle over a side. So if I look at what I have left, I have this right here. My angle is 71 degrees. My side value is x. That's what I have to find. Which one of those values goes on the bottom? What goes on the bottom? The 35 or 71 or the x? The x goes on the bottom. The bottom is always going to be your sides. The bottom is always going to be your side lengths. We don't know what that is. We do know what the angle is. So this is going to be the sine of 71. So now we have a proportion set up. And we know how to solve proportions. We do the cross products. So I'm going to take 12, close. I'm going to take 12 times the sine of 71. I don't know what that is. It's just a number. We'll use our calculator in a minute. That's going to equal the ratio of x times the sine of 35. I'm going to move this over so it's easier to see. Now, ultimately, we want to solve for x, right? So what do I have to do? I don't want to sine of 71 and sine of 35. I could punch those into my calculator and get decimals, but then I have to round and I have to do a whole bunch of other stuff that I really don't want to do. What could I divide the right-hand side by to solve for x? I could divide by, so let's say that this said 12, let's say that this said 12 equals 6x. What would I divide both sides by? 6, right? I divide both sides by 6. Well, I don't have 6 here. I have the sine of 35. And I'm going to take this and divide this by the sine of 35. So now in my calculator, what I'm going to do is I'm going to take 12 times the sine of 71. So break out your calculators. You're going to need them. If you don't have them, I've got several over here. Most of them work. You're going to take 12 times the sine of 71 on your calculator. So just hit 12 sine 71, close the parentheses and hit equals. Now don't do anything. On your calculator right now, you should have like 11.346222291. We're going to divide that now by the sine of 35. My gosh, must be Tuesday. We're going to divide that by the sine of 35, and that's going to give us our x value. So all you have to do, you have that 11.34, hit the divided by key, hit sine 35, close the parentheses, and hit equals. You get 19.8. So the length of that side is now 19.8. Okay. So we set up what we call that master ratio. The master ratio is always going to be the angle that you know and the length of the opposite side you know. That's your first one. And then you're going to set it up with whatever else you know. Okay, so let's look at the second example. I'll get rid of this 12 equals 6x now. Let's erase that. Okay, so I know this side, and this angle is the side opposite it, or the angle opposite it. So my master ratio is going to be the sine of my angle 18 over 5. The other ratio that I have is this right there. So what goes on the top? 114, but make sure we put the sine of it. So the sine of 114 over x. We have our proportion set up. So we're going to cross multiply 5 times the sine of 114. And then what am I going to divide that by? Just going to divide that by the sine of 18, aren't I? Because remember, that's equal to this cross product, which was just x times the sine of 18. So we divide both by the sine of 18. So calculator, it's 5 sine 114. And you need to make sure, hit the equal sign after you hit 5 sine 114. So you should have 4.56, blah, 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 blah. Then hit divided by sine of 18. Close your parentheses. 14.8. Is that what we got? So now we know the length of that side using the law of sines. And as long as you know an angle and its opposite side and one other thing, you can find everything else. Okay. Let's take a look at this one. I want you to go ahead and do this one. So you can find the value of x, rounding it to the nearest tenth. Round to the nearest tenth.
What's the date?
What is the date? It's the 18th today. Everybody wear green yesterday? St. Patrick's Day? No? I didn't either. We had to sit in here in professional development all day yesterday. It was great fun. Any luck tomorrow we'll have 25 inches of snow on the ground and not be here. No. Do not want any. I'd rather be here than have snow again. We just had a week and a half off. So sine of 73 over 20. That look right? Equals the sine of 59 over x. Can everybody set this up? Are we good setting this up? Okay, cross products. We're going to go 20 times the sine of 59 and divide that by the sine of 73. So 20 sine 59 equals divided by sine of 73. 17.9. Any questions how you find missing sides? It's not so bad, right? And the ratio is always the same. Now, it's not just finding sides. We can also find measures of angles, doing the same thing. And really, for the most part, it's the same thing, really, as far as setting up the proportion. You're looking for the angle and the side opposite it. But now this time, our unknown is going to be our top number. So if we look at this one, I got to go plug in over here. I'm about ready to lose power. Be more interesting to see if this still works up here. I don't know if I've ever done this. We're going to try. All right, so if we look at this one, here's the ratio that I know. I'm still going to use it. So we're still going to go the sine of 77 over 14. That's still the same. But now, when I set up this second ratio, I know the length of the side is 9. So this top now is going to be the sine of x. Setting it up makes sense. Okay, now let's do the cross products. Now I'm going to do this one first, this top first. I'm going to go 9 times the sine of 77. That's going to equal 14 times the sine of x. What do I have to divide both sides by? 14, right? So those 14s make 1. So again, I grab my calculator. 9 times the sine of 77 equals divided by 14. Now don't write this number down yet, but you should have something like 0.62638, right? That's equal to the sine of x. Is that an angle measure? No. How do I change that? Do you remember how do we change a decimal to a, how do we change the decimal ratio to its angle? A key that we have to use on our calculator. Second. So if you leave that there, that's right there, that, I'm just show you a shortcut. Hit second, hit sine. So now your calculator should say this with a parenthesis, but now what you're going to do is you're going to hit the second key and then hit the negative symbol. And now your calculator should say this. Close that parenthesis. When you hit second and the negative symbol, it puts the last answer you had in that spot. So you don't have to write it down. Now if you hit equals, it's 30, let's round it to the nearest degree. It's 39 degrees. So there's one additional step that you need to do when you're trying to find the measure of the angle. You're always going to get a decimal down there. Okay? And it's always going to be 0 point something. If you get 1 point something, you've done something wrong. Because the ratio of the sine, remember the hypotenuse is always the bigger number. And that's the bottom number of sine. That hypotenuse has to be bigger than 1. Okay? That has to be the biggest side. So you're never going to be bigger than 1. So if you're trying to find the measure of an angle and you get 1.843 equals sine of x, you can't do that. You get an error. So that should always be 0 point something. If you don't, check your math. Hit second sine, and it's always second sine because it's the law of sine. We find the measure of the angle. Okay, so let's look at another example. All right, so I look at what I have. There's my ratio that I know. Again, I'm just circling the side in the opposite angle. My angle goes on top. So that's the sine of 126 divided by 31. Where does the 15 go, on the top or the bottom? Bottom. 15 goes on the bottom. The sine of x goes on the top. Cross multiply. 15 times the sine of 126. We're going to divide that by 31, right? Just kind of save ourselves a step of writing. So 15 sine 126 divided by 31. Again, you don't need to write this down, but you should have 0.3914598 dot, 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 dot. So our decimal is less than 1, which is good. Now we have to hit second sign, second negative symbol, hit equals. I got 23 degrees. So now we know the measure of this angle is 23 degrees. Now we're not going to talk about this today. Could I find the measure of this angle right here now? What do these three have to add up to? 180. So I could find the measure of that angle, right? And if I knew the measure of the angle, I can use the law of sines to find the measure of that side. So we could solve the whole triangle. We'll get to that. Today we're not going to go that far. Today we're just going to be given these pieces and try to be able to find them. Okay. Go ahead and see if you can find the measure of angle X down there. This will be the last one that we do if we can get through this successfully. Give you about 2 minutes. Did anybody leave this in here? That's fine. Should be fine. Oh, it doesn't do that.
It doesn't do the negative, not do it just as a negative.
Okay, and we'll find it. Oh, it's right there.
Oh,
So you just hit that key. There you go. Yep. To use is even easier. Just have to hit that key. Even better. I should have said something. Are we okay with the setup? Sine of 25 over 12 equals the sine of x over 28. Questions with the setup? Cross multiply 28 times the sine of 25. Going to divide that by 12. To bust out a calculator. 28 sine of 25 divided by 12. 0.986109277. We need to find the measure of the angle. So second sine, find the answer. Round to the nearest degree. 80 degrees. All good? Any questions with that one? We okay finding missing sides and missing angles of triangles if you're given to use the law of sines?